Hi friends, welcome to the Eureka Learning's YouTube channel. I am Pawan Sai Tadepalli. Today I come up with a new interesting video friends. This is video about data science project. So in this video I am doing a data science project called perfume classification using machine learning. So this video is very interesting friends, and this is one project video for beginner levels and not intermediate levels. This video will be very helpful. So let's go into the video, friends. So this is perfume classification. So what is the problem statement? To classify the perfumes based upon the observations. So in the data we have observations. Based upon these observations or using these observations, we need to classify the perfumes. So coming to the dataset information, this dataset consists of odors of 20 different perfumes. Means there are 20 types of perfumes are present in the dataset. This data was obtained by using a handheld odometer from this sensor per second. So per second they collect the data. So how many periods, how many seconds they collect the data means they collected for 28 seconds means for each perfume we get 28 observations. So from this we can conclude there are 28 columns for the each perfume. Coming to the attribute information friends, attribute the name of the perfumes are these are the perfume names to tea, trial, raspberry, rose musk, strawberry, etc. So we have to classify these perfumes based upon the observations. From this we can understand that this is a classification task. So this notebook demonstrates how a machine learning model can determine the type of perfume based on the odometer rating, friends. I think you understand about the data, friends. So let's go into the implementation part. These are the these are the necessary libraries to do this project: NumPy, Pandas, Matplotlib, Seaborn. These are the common libraries, friends. And for I am using decision tree and random classifier for because this is a classification problem. And I am using these two algorithms. Why I choose these two algorithms means uh, if you don't have time to process the data and the client asks you to I need to faster delivery of this project, so decision tree and random forest tree based algorithms are best, because if you want to do outlier analysis, anomaly detection, missing values, so it takes so much time to do this data analysis. But if you use this decision tree classifier or random forest classifier, so we don't need to do that type of process, because these two algorithms are very best in that process. They will classify automatically based upon the entropy values or Gini values. So I am this is a classification task, so that's why I'm taking accuracy score and confusion matrix and label encoding. Why I take label encoding? Because in the data set these perfumes are in English letters, so computers can't understand, or our models can't understand these English letters or text. So we have to convert this text into numerical format. So that's why I take this label encoder. So I am ignoring the warnings, friends. So which warnings I am ignoring? Like depreciation warning, user warning, and runtime warning, and future warning, friends. So this is the syntax for filtering the warnings. And I am setting the number of rows and columns for this. To set this number of rows and columns, this is the syntax, friends. pd set underscore option for rows and columns. So you can give the number. Normally I gave this number. After I am doing this project in Google Colab. This Google Colab is a very free source. It has a GPU access, friends. For me it gives 1 minute, friends, I will show. So it gives 12.72 GB of RAM and 107.7 108 GB of ROM, means hard disk. So it is freely available from the Google, and this is very it has inbuilt Jupyter notebooks, friends. We can change the settings of GPU, or we can run all the settings. We can insert like text or Q markdown like in the Jupyter's. We can add text or anything. If you want to get about notebook information in the view section, we can get this notebook information. And in the edit section, we have to copy or cut the cells. Like you want to hide the code section and paste the section, you can do these tasks. And this is all about the Google Colab, friends. So this is a cloud platform. So we have this will be connected to our drive, friends. So from the drive, we can get the data, or you can upload the data from the locally also using files dot get upload function, friends. But I don't use that function. So first I am accessing the my drive using this syntax from google.colab import drive, and I am mounting my drive, friends. After you run this command, this will give you one link. If you click on that link, it will redirect it to next page, and you need to allow the permissions to access your drive. After that, you will get one code like for security purpose. You have to copy that and paste it here. Then you will you can mount your drive in this Google Colab. So after I am getting my data, so this data in Excel format, Excel sheet. So I am using this syntax pd.read underscore Excel function, and this is my data bar. And I didn't give any header. If I give a header, because it not looks beautiful, so that's why header I put header equal to none, friends. Next, I am printing the top 5 rows, friends, using data.head, because I gave my data to data variable. That's why I'm using data.head. So see, friends, there are, I said already in the from so each 28 seconds they collect the data. So we have 28 features, like 28 numbers 0 to 28. See, means 0 column is the perfume name, friends. So these are the perfumes. So find let's go into the finding the total how many observations we have. I am using length of data command. So total 20 observations. Total 20 observations in the data set. Finding the total number of features means at columns. Length of data dot columns 29, including 0. 28 are uh, why 29? Because 28 are observations and one column is the perfumes names, means text column. So total 29 features are present in this data set. So I am using this data dot share command. We can know the about the data set information. Next, in the 0 column, we have perfume names. So we have to change this into labels or anything or perfume. You can put your name. I am putting perfume. I am giving a column name as perfume. Then I am so our perfumes are in data of 0 columns. So I am assigning this column to this data of new column perfume, and I am dropping the 0 column because already assigned this data to perfume columns, and I'm giving a new variable name called data one. Then I am printing the data one column, friends. See, in the last column, I am perfumes are coming, because we can easily separate independent variables, dependent variables. So I put in the last column, friends. So this is the data. See, 28 observations. See, friends, 28 observations. Uh, this is about the data, friends. After converting, and I am printing the perfume names for understanding purposes. So the all perfumes are in the last column. So I am using I am using list data type to put all the perfumes in the list, and this perfumes column is in the last column, so I am using this syntax data dot iloc of -1. So it prints all the rows. -1 means last column. So name of the perfumes present in this data set, perfumes. So these are the perfumes, friends. So these are the Ajmal, like this rose. So these are the perfume names. Next, coming to the data cleaning, friends. In the normally in the data cleaning, we check null values. Is there any null values in present in this data set? Using this command, we can check the null values. So and we can know how many null values are there using this syntax data one dot is null dot sum. Look like there is no null values, friends. So there is no null values in this data set. And after each command, you can put this text, friends, because this is a storytelling of the data notebooks. This is very important, friends, while doing the projects. So after because in the companies or there are so many people are working in simple single projects. So if the you are doing one task, another person doing another task. So for better understanding, if you do like this, the people will understand easily, friend. This is very important while doing data science projects. Storytelling of notebooks, storytelling is very important, friends. Then let's go into the information about the data. We have to know how the data is on which data types in the columns are. So there are total 2019 columns. Using data.info, we can get the information about the data on 20 entries. Total 29 columns. There is no null values, and all columns are into integer format. Only last column means our dependent variable dependent column is the object, means it is a text now, that's why it is showing object, and the dataset size is 4.7 kb. So at each row in the data frame consists of 28 odometer measurement values and the corresponding name of the perfume, friends. See why? Because this data, so for each perfume we have 28 observations, friends, but there is no need to do like this, because we can assign this each perfume to each observation. So all are these all are only one, like look like say one feature, and this look like say another feature, friends. So you can convert it to two features. So let's go into that part, friends. So at each row in the this has to be converted into which has each row observation as a row and each attribute as a column. For this, a new data frame is created and the values are appended correspondingly, as I said. So I am taking a two new features, friends. I am creating a new data frame with empty data frame and putting columns names as observation and perfume. If you print this data frame, it looks like this, friends. Because it is an empty data frame. I didn't give any data. So now we can append these observations and perfume names to this data frame, friends. This is the important part, friends. And listen carefully and watch carefully. Observations. I take two variables, observations and labels, and I am these observations and labels are giving an array. I am not taking any list data type or any dictionary data type, friends. For these variables, I am using array format and using np.array and np.array. So these two features are in array data type. So we have to convert each perfume or corresponding observation. Each perfume corresponding observation. So that's why I take. So for each perfume we have observations. So for I am running for loop, friends, for perfume in range of length of perfumes. So this loop should be run because we have 28 observations and for each perfume. So we have to collect these 28 observations regarding the perfume. So I am for this loop should run how many perfumes are there. That's why first I take this for loop for perfume in range of length of perfumes. It gives numbers as an output, and for, so we run these perfumes. We know the perfume number. So for each perfume, we have to append the observations. That's why I'm running another for loop, friends, for in range of 27. As we already know, there are 28 observations, 0 to 27, friends. That's why I take as a 27. And I am assigning to variables observations, comma labels using, you can append using, because normally this data is look like all observations and perfume names. That's why I'm taking as C, friends. I am using data.iloc command. So data one dot iloc of perfume. So in the perfume also we have the integers and this have the integers. So for this data.iloc command, we need for row and column number. That's why I take this perfume and I. In the I also, in the I command we have observations number like, and in the perfume we have, so this come into column and row. And same thing for labels also. We have to take the labels. And that's why for that also I am using data one dot iloc perfume. But these perfume labels, perfumes are in the last column, friends. So that's why I'm taking as a perfume comma minus one. So minus one means in the last column it will take. After I'm appending this observations comma this OBS variable into observations, because these are all observations. And after I am up, we need to append the labels. So using np.append, I'm appending this label part to labels variable. So this is about appending the date corresponding each observation to perfume. So after I am converting this array to series format for printing the data frame structure. So I am converting these observations and labels using pd.series of data. We already created two columns named friends, observation and perfume. So I am assigning these two observations and labels to these two new curated column, the dot observations equal to observations and the dot perfume equal to labels. Then we can print a series object, friends. So this will be look likes. So this is the perfume name. This is the observation corresponding this perfume. So total number of observations will be 540, friends. And number of features will be 2. And I am printing the top 5 observations. So these are the top 5 observations. And I'm getting the information about the data after converting the two features. So columns, total 2 columns, 540 observations, 0 to 539 index, and column name observation and perfume. So total 540 observations and no null values. And observations are float and the perfume names are in the text. That's why it is object. And total the size will be 4.8.6 KB. And the normal data set look like for all the observations we have corresponding data, because this data look like all some I will say like for this perfume we have all 28 observations first. Next, after 28 another perfume will come and corresponding all the observations will be one part. But if you do like this, so there may cause when we are building the model or using machine learning model, the model may bias. So it memorizes the this data. If you give new data, the score accuracy score will be decreases. To avoid that problem, I'm shuffling the data set, friends. So I am shuffling the data set for avoid bias issues using df.sample. So this is the syntax friends frac, and I am giving one. If you give, if you want to wish to give, you can give. Otherwise, no need. I am using random state, and I am changing the index. So top five observations after shuffling friends using df.head command. So data will be shuffled. So we have to know about the perfume, each perfume. We have to know about the statistics. So that's why I'm using descriptive method. Means it gives descriptive statistics. We did a data frame of df group by. So I am grouping all the observations related to each perfume, and after I'm transposing for corresponding each perfume, we get descriptive statistics. The mean of the each perfume, rose mask, tree oil. This is the mean, friends. And for rose mask, we have standard deviation 0. Means it is look like a normal distribution, but all are deviated. Means there will be a skewness present in this data set. And this is the minimum value, and this is the maximum value, and 75%, 50% value. So this is about the descriptive statistics, friends. So after we get as a table format or data frame format, but we can use bar plots for know the values, friends. So that's okay. Next part is bar plot. So df dot group by perfume dot mean dot plot using bar plot. This is the figure size, friends, and I am giving y label as a mean of measurements. So this is the bar plot for each plot. What is the mean? So for rose musk is the high mean. Next to tea tree oil and raspberry is the highest mean. The lowest mean is the solid musk, friends. After this is about the perfumes means, and I am drawing the distribution. I want to know the distribution of the each observations. So using this command, we know the distribution of the observations, friends, as soon as the distribution, plot of df dot observations. See, because all values are from 5500 to 7500, friends. Main, no, most of observations only normal some observations are below 4000, 5000 to 4500, and some observations are very high, above 8000 to 8500, 85,000 to 80,000 to 85,000. So this is about the distribution of friends. See, friends, this distribution part look like mm, near equal to normal, but variance is more because some data is 45,000 and near to 5,000, and some data near to 85,000, friends. So variance is, we can say variance is high in these observations from this distribution plot. After I am converting labels to, I'm using label encoding, friends, for converting text to numerical format using label encoder. I am importing label encoder, friends. I am assigning this label encoder to LE, and so after transforming this label encode to giving this column or feature df of label, so all the encoded labels are in the this new column, label column. And next, I am converting observations to 1D format. I am reshaping the data, this column, into one difference, single vector. Why I converted to, because the shape will be, if the shape is not like this, so we can't fit. to the our models, friends. This is the problem. That's why I'm converting to reshaping to 1 comma 1 minus 1 comma 1 means all, and our dependent feature is label, independent feature is observation, friends. And I am not doing any data analysis, friends, because I am not using any scaling. Why? Because all the features are in the same scale. You can see all the features are in thousands. You can see in the starting, you can know. See, friends, all the observations are in thousands. Normally, one feature is one scale like 1 to 10 or any, and some features in thousands, some features in hundred. At that time we have to do scaling. We have to use scaling techniques, but there is no that type of observations are not there. All the observations are in thousands, so uniform scaling. So there is no need to do scaling. So we have to observe this type of kinds things, friends, from the data. Normally, so many people are using scaling without necessary also. So first we have to observe the data carefully. After observing the data, we have to follow the steps. And outlier analysis is also not required, friends, because some perfumes are give very good smell, strong smell. Mm, so means if the concentration of is very high, the concentration of chemical is very high, so the odometer sensor gives very high reading, but those are not outliers. We have to observe this thing, friends, because normally we think outliers are very extreme values are very low values. That is works for some data, but we have to know about the data. We know the subject of data, friends, and what is the data and what is the application. So but this task we don't need that do outlier analysis, because some perfumes are very highly concentrated. So at that type of perfumes will get very high means high observations, but that are not our outliers, friends. We have to observe. That's why I'm not doing this outlier analysis, and there is no need of dimensionality reduction, because normally we do dimensionality reduction for know the important features for feature selection only. But these are only observations and perfumes, one independent label and one dependent variable. So there is no need of dimensionality reduction, uh, because only two features, one is dependent and one is independent. So there is no need of do feature selection or feature engineering, friends. So I am not. That's why I'm not doing any feature engineering or feature selection and dimensionality reduction techniques or outlier analysis on any scaling. Why I doing this video? Because we have to observe the data, friends. That's why you can know better information. That's why I'm doing this video, friends. Next part, friends. Next, we have to split the data. But I am using only label and coding, because converting this independent dependent variables to numerical format. See, friends, I'm using train underscore test underscore split. So my training data is 70%. I'm taking test data is 30%, friends. So I am using decision tree and random forest models. I am importing decision tree classifier because this is a classification task, and fitting the my data train and train and white train data and predicting using testing data. I'm predicting. So I'm printing the accuracy score, friends. Accuracy score of y test and y predict. It gives very accurate score, because why it gives very high accuracy score without doing any analysis or any feature engineering, friend? Because we have uh, Use data. The data will be useful. That data will be enough for classifying the task. If you classify, if you use the data correctly, we can get the good results without doing any analysis, without putting any too much effort, friends. That's why I have to say to you, I have to say that part. That's why I'm doing this video, friends. And for decision tree, it gives accuracy score as 1. Let's check with the random forest, friends, how much score it will give. And I am importing the random forest classifier and fitting my data and predicting the test data. See, friends, it also give one accuracy score of 1, because these two will give work hard same, only some principal difference, but these are coming to decision tree based algorithms, friends. So this is about the perfume classification, friends. So because this decision tree or random forest works better for this data without doing, because there is no need of do outlier, or if you want to do outlier analysis or any type of process, any type of data analysis, and if your data consists of very high null values, but these tree based algorithms works fine, friends. Remember this point. uh, these two gives very high accuracy score, friends. This is about the perfume classification, friends. I hope you like this video. If you like this video, please give a comment and please press like button. And if you don't subscribe my channel, please subscribe my channel, friends, and please share to your friends. And thanks for watching, friends. Thank you.